Question 7, starting with the graph of a basic function, graph the following function using the techniques of shifting, compressing, stretching, and or reflecting. Find the domain range of the function. So notice how we have this degree 3 function. So our parent function is actually this y equals x cubed. So that would be like our f of x. So notice that if we have inside f of x minus h or f of x plus h, this is going to be considered horizontal. So notice how there's this minus 4 inside here. So that means we're going to be going to the right 4. It's always backwards. So we're actually doing this one. So that means we're actually going to the right. If it was plus h, then we would have went left. And notice how this plus 1 is on the outside. That's like this plus k. So that's going to be a vertical up, because what you see is what you get on the vertical. So that's going to be up 1. So if I understand the parent function y equals x cubed, so if I graph that function, it'd be like 0, 0, 1, 1, and -1, -1, if you will. It's the snake function that runs along the y-axis. So really what's happening is this graph here is making the graph move right 4 and up 1. So each one of these points is moving right 4 and up 1. And that's all we're really doing is doing the shifts. So this would actually be 1, 2, 3. So right 4, 1, 2, 3, 4, up 1. This point would be right 4, 1, 2, 3, 4, up 1. And this point would also be right 4. So 1, 2, 3, 4, up 1 would be here. So notice the snake should actually now take on this look here if I was applying the transformations. So if I graph these two on the calculator, clear and clear, we have x cubed goes in. Then we have x minus 4. So x minus 4 was inside, cubed. And then come down, plus 1. I think that's the function we had. Yeah, that looks correct. So if I graph those two functions and notice that the snake was at 0, 0, now it's like 1, 2, 3, 4, up 1. And that's kind of what we did to the graph. So if we're applying the transformations, the compressions don't change, the ones and ones don't change, but the vertical shift, we would be moving that to 1. So we will make this go to 1. And then the horizontal shift, we would also make that go over to 4. So we would slide this bar over. And there's not any reflections about the x-axis or y-axis. So all we really have are those two things to contend with. So by doing so, your graph should get generated where you should see this point here, this point here, and this point here, if you will. And this graph kind of snakes around like so. Should take on that look. Okay, so I don't think I did a good job moving this point here up, right 4 up, should be actually up to there. So I didn't really make that point move really well on my graph. That looks much better over here. So that's what you should see as your graph goes. As far as domain goes, notice that there was not any division by zeros and there wasn't any square root symbols in there. So the domain, you can kind of see it is moving left, it is moving right. So the domain really is everything, -infinity to infinity, all real numbers. The same with the range. Notice how there is no lower bound, there is no upper bound. There aren't any range restrictions either. So the range value should go from -infinity to infinity as well. You can also probably see that in a table. So if you go to the table, if you look at your y values, again, we're talking about the red one. Notice that I have to see here. So if you just follow the red ones there, notice that the red ones, I can keep going left and it just keeps going down. That's what our graph is doing. As we go left, the graph is going down. So I don't see where I can't keep going left. I can just keep going left forever. As you go to the right, as you go to positive infinity, notice that as you go right, notice how the y values are also getting rather large as well. And I don't see any end to that either. You can just keep going right and you keep going down. So there aren't any domain restrictions on either the domain or the range. There's no boundaries, if you will.